This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Today's discussion centers around an intriguing interactive physics simulation, coin sliding or rolling JavaScript simulation Applet HTML5. It's a fascinating example of how technology is transforming physics education.
Indeed. Interactive simulations offer a powerful way to bridge the gap between abstract concepts and concrete understanding, particularly in a field like physics where visualization is key.
Exactly. This particular applet focuses on the turning effects of forces. How does it achieve this?
It cleverly uses a simple, relatable object, a coin, to demonstrate complex principles of rotational and translational motion. Users can manipulate variables to see how things like friction and the point of force application affect the coin's behavior.
So it's not just about watching a pre-programmed animation, it's about active experimentation. Let's delve into the core concept, interactive physics learning. How does this simulation enhance the learning experience compared to traditional methods?
Traditional methods often rely on static diagrams and equations. This simulation allows students to actively engage with the concepts. They can change parameters, observe the results in real time, and develop an intuitive grasp of how forces interact. It's learning by doing.
And the ease of use is a significant factor, isn't it? The description mentions user-friendly features like combo boxes and adjustable parameters. The simulation's accessibility is another key aspect. It's built using HTML5 and JavaScript, making it readily available across various devices and easily embeddable in web pages.
Precisely. The use of HTML5 eliminates the need for plugins, ensuring broad compatibility. The iframe code makes integration into online learning platforms seamless, expanding its reach and impact. This aligns perfectly with the OER movement.
Speaking of OER, the simulation's open-source nature is crucial. What are the benefits of making educational resources freely available?
Open access democratizes education. It removes financial barriers, allowing educators and students worldwide to utilize high-quality learning materials. It also fosters collaboration and continuous improvement as the community can contribute to refining and expanding the resource.
The simulation specifically targets the turning effects of forces, a crucial concept in Newtonian mechanics. How does it effectively illustrate this?
By allowing students to manipulate the initial conditions, things like initial velocity, normal force, and friction, they can directly observe how these factors influence whether the coin slides, rolls, or a combination of both. This visual representation solidifies their understanding of torque and moments.
You mentioned the ease of use. The document highlights adjustable parameters like W, U, N, scale, and dt. Can you elaborate on what these represent?
W likely represents angular velocity, U linear velocity, and the normal force, scale a scaling factor for visualization, and dt the time step, which controls the simulation's speed and accuracy. These adjustable parameters allow for a wide range of experimental scenarios.
The document suggests various applications, from classroom demonstrations to homework assignments. How versatile is this resource in a broader educational context?
It's incredibly versatile. Teachers can use it for demonstrations, students for self-guided exploration, and it integrates seamlessly into online learning modules. Furthermore, the website offers a wealth of related simulations covering various physics topics, creating a comprehensive learning ecosystem.
The accompanying study guide includes a quiz and answer key. This is a valuable addition, isn't it?
Absolutely. It provides a structured way for students to test their understanding of the concepts demonstrated in the simulation. The answer key offers immediate feedback, reinforcing learning and identifying areas needing further attention.
The study guide also features essay questions, encouraging deeper critical thinking. What kind of insights can these questions elicit?
The essay questions prompt students to analyze the simulation's pedagogical value, its advantages over traditional methods, and its role in creating a more inclusive learning environment. They also encourage reflection on the limitations of simulations and strategies for maximizing their effectiveness.
The inclusion of a glossary is a thoughtful touch, ensuring clarity and understanding of key terminology.
A glossary is essential for defining technical terms, ensuring that students have a solid foundation of the vocabulary used in the simulation and related concepts. This promotes clear communication and comprehension.
The document includes sections on sample learning goals and instructions for using the simulation. How important are these elements?
Clearly defined learning goals provide a framework for the learning experience, guiding students towards specific objectives. Detailed instructions ensure that students can effectively interact with the simulation and extract maximum learning value.
The FAQ section addresses common questions about accessing, embedding, and using the simulation. This is a practical addition.
A well-structured FAQ section proactively addresses potential user challenges, enhancing the user experience and ensuring smooth implementation in educational settings. It also demonstrates a commitment to user support.
This discussion has highlighted the significant potential of interactive simulations like the coin sliding or rolling applet in revolutionizing physics education. Your insights have been invaluable.
The combination of interactive engagement, accessibility, and open source availability makes this type of resource a powerful tool for enhancing learning outcomes.
That was a great discussion. Thank you.